Pradyumna. What are anti-friction bearings? Sliding friction is converted to rolling friction. This is how we define anti-friction bearing. Pranay. Sarthak. Are you there? Pranay, Sarthak. Vaishnavi. Rollers are used to reduce friction. Rollers are having surface finish, therefore anti-friction. Okay. Shabya. Anti-friction bearing designed for radial loads. What about journal bearing? Amay journal bearings, are they designed for axial load? Amay. Let's start our discussion today with the comparison of sliding bearing and rolling contact bearing. We have already seen different types of roller bearings. We have discussed about ball bearings, their nomenclature. We discussed about the Hertz contact stress. We have to discuss about the roller bearing. We have only discussed about the ball bearings. So let us compare and contrast journal bearing also known as sliding contact bearing. With roller and ball bearing known as rolling contact bearing. Another name for the journal bearing is hydrodynamically lubricated bearing or hydrodynamic bearing. Here another name is anti-friction bearing. So if we talk about the basic difference between the journal bearing and a ball bearing or a sliding contact bearing and a rolling contact bearing is journal bearings are normally suitable for radial loads only. They can withstand a small amount of axial, but essentially designed only for radial loads. Whereas these roller and ball bearings, they can take both radial and axial. In hydrodynamic lubrication, the oil film is formed at a particular speed. So if it is not rotating, there is no hydrodynamic lubrication. So this starts taking the load, and the oil film is formed at a particular speed. Ball bearing, it can take load even when it is not rolling. Even at rest. Here when it is at rest, you know that there is a direct contact and the oil film is not formed. So after there is a convergent film formed and there is a pressure distribution that the minimum oil film thickness is maintained. Okay, give me more points. Give me more differences. Rishikesh, Deepika, more friction in journal bearing. Yeah, so that friction is reduced only with oil. So if we can say that the friction is more if there is no oil. Or we can as well say continuous lubrication is required to minimize the friction. Continuous lubrication is required. To reduce friction. Shear force acts on first case where rolling contact pose. Yeah, this is a good point. As against this, no lubrication is required. Continuous lubrication is not required, you can say. Okay, about temperature sensitivity. Okay, what else? Shear force. Okay, so here the kind of force or the hydrodynamic lubrication works on the concept of shear force between the oil or between the layers of oil, and here there is a concept of contact stress between the rollers, which is the governing parameter. Okay, so because of continuous rotation, large amount of heat is produced here, which needs to be dissipated again with the help of oil. Large amount of heat is generated. Then it has to be dissipated. Here, since it is anti-friction, The heat generated is not significantly high and we don't have to worry about the heat generation here. We can say that it is generating less heat. What else? Can you talk about space? Which bearing will take less space and which will take more space? Anybody can comment on the space? Manas, ball bearing will take less space. Journal bearing will take more space. Anybody? Roller will take more space. So if you look at the figure, if this is the journal, this is the shaft over here. Journal bearing would be like this. This would be the bearing and the journal, wherein this is taking more space along the length and less space along the radius. Whereas here, if this is the journal or the shaft, this is taking more space in the radial direction, less space in the axial direction, more radial space. Do you agree? Here, more axial space. Along the axis, it is taking more space. We are taking this L by D ratio greater than 1, which means that along the axis, this length is more. So this much space is required. You cannot place a bearing outside the journal in this much small space in case of journal bearing. Whereas here, the space along the radius is more, along the axis is less. Can you talk about shock absorbing capacity? Which one do you think can absorb more shocks? Or the vibrations would be less in which case? Rollers will absorb more shock, less vibration. One of these two is using oil, and it would be like, what do you call it? Hydraulic shock absorbers. So oil which is flexible will absorb more shock, or balls which are rigid will absorb more shock. Oil will absorb more shock, always. So anything which will have more flexibility, a liquid will absorb more shock as compared to solid. So with this logic, because of the formation of oil film, this can better absorb shock as compared to this. Since this is solid, this cannot absorb shocks. This is good for frictionless motion, but not designed for shock. Can you comment on failure? Can you comment on how this would fail and how this would fail? When would a journal bearing fail, or how do you think it would fail? Right? So wear and cracking of bearing. Which bearing you're talking about? Cracking of which bearings? Ball bearing. Would that be sudden or gradual? Will there be any indication of failure? Gradual excessive wear. Okay. Uh, Now look, both will have some lifetime after which it would fail. But the best part with the sliding contact bearing is before failure, this will become red hot. And this would happen only if excess amount of heat is generated and less amount of heat is dissipated, which is again because of any supply of oil. So before failure, it will give an indication, it will turn red hot, which is an indication before failure. So we always want there should be some warning signal before it fails. Here, we have seen yesterday because of the contact stress, if there is a bearing, the maximum stress is somewhere near the periphery, not on the periphery, but inside this bearing, and the crack will start developing here, and gradually the crack propagates. We can see once this ball is completely fully cracked, we cannot see that a crack is developed inside. And since this stress, contact stress, will be uniformly distributed on all the balls, the ball bearing will suddenly stop working, and then there would be a lot of noise, which indicates that this is already failed. You must have heard in fans normally. So the ceiling fan or the table fan, they'll start making huge noise, and immediately your technician will say that iska bearing gaya hai. Ever heard this phrase? Yes. So this could be a sudden failure, or failure is although though gradual, but there is no indication. So you will never get to know that this is about to fail. So there is no indication of failure, and it will suddenly stop working. So as if there is a metal to metal contact, and that is creating that large or a heavy noise. So there is a sudden failure without indication. When I'm saying sudden, it is because we are not getting to know that this is about to fail. It will fail, and then we get to know. Although this phenomenon of generation of crack and propagation of crack, this is slow, but there is no indication. This is bad in industries and factories. What about the alignment issues? Which one will have more alignment issues? This is having large amount of clearance. And we have seen that their axes are never aligned. It is always having some eccentricity E, isn't it? So there is always some eccentricity E, and there is a huge clearance, and the axis of the shaft and the axis of bearing, they are never aligned. So this will always have some alignment issues. When we talk about the alignment of the shaft and the bearing, but for less clearance, for smaller diameters or the smaller radial clearance, this alignment issues can be handled. But in this case, the alignments are good. And the reason is the clearance is very, very small. So the center of the inner race and the center of the outer race will usually be properly aligned. Less clearance. What about cost? Which one do you think would be costly? Roller contacts? You are right. So this one is cheaper. Ball bearings and roller bearings, they are costly. Cost-wise, these are expensive. But then these ones are good for precision. So although they are higher, but it is easy to install, easy to replace. So you remove the damaged bearing, look at the rating of the bearing or the nomenclature given over. If it says it is 1415, you have to go and just buy this and place it here. So it's very easy to replace. This is good for precision. That makes it costly. These ones are not easy to replace. Although they are simple in design, in assembly, but not easy to replace. So this comparison is important from the concept of understanding the difference between these two bearings. Okay, so to be honest with you, in one of my interviews, in my very initial phase when I was not teaching this subject, and I don't remember having studied this topic very seriously during my engineering days, and I was asked questions only on bearings, difference between axial bearing and thrust bearing, difference between axial bearing and journal bearing, difference between ball bearing and roller bearing, and I was so utterly confused that I was giving all sort of random answers that ball bearing is using oils and roller bearing is anti-friction bearing and thrust bearing is similar to roller bearings, so I got messed up with all these terms. So that happens because you have not seen these bearings working. That happens because you have not studied properly. So if you can compare two different bearings properly, then although there are three names given to each of them, but you would know what is a journal bearing, what is a journal and how a journal is different from bearing, and how a journal is an extension of shaft, and how here there is a sliding contact between the journal and the shaft, although this journal is rotating inside this, but for this the long length of the journal inside the bearing, this the type of contact is a sliding contact, and because there's continuously in rotation and an oil film is formed, so this is also known as hydrodynamic lubrication. Whereas in the ball and the roller bearings, the type of contact between the inner race and the outer race is a rolling contact, and these are very smooth because of very high surface finish, and they are pre-lubricated. At the time of installation, they are lubricated for its life, for its finite life, or its one-time lubricating. So continuous lubrication is not required. So these are also known as anti-friction bearing. So if you are confused, then there is a chance that your examiner or your interviewer might ask you the difference between anti-friction bearing and rolling contact bearing, and what is the difference between a ball bearing and an anti-friction bearing, and then you are confused. So if you properly understand why three names given to the same bearing, or why it is also known as rolling contact, why it is also known as anti-friction bearing, then there is no chance that you are confused. So please feel free to ask questions if you have any. Yesterday we discussed about ball bearings. Let us see how roller bearings are slightly different from ball bearings. Now, as against ball bearing where there is a point contact, in a roller bearing there is a line contact. And if the balls are perfectly spherical in shape, rollers are cylindrical in shape. So your rollers would be like this. And hence the cavity for this roller bearing will also be different. This is the outer race. There would be a pocket for placing a roller. And there would be a roller inside this. So your roller would be like this. Which can take the radial loads coming along the radius of the shaft and axial loads coming around the axis of the shaft. And you know that this is the shaft. This is another point of confusion, which one is the radial load and which one is the axial load. So along the radius of the shaft, you have the radial load. So this is a simple roller bearing. Now there are variations in the roller bearing. If you want it to withstand more axial load, more than the radial load, if FA by FR, if this ratio is high, which means high axial load, then tapered roller bearing is used.